Okay, here we are, and welcome to part 2 for our ideal stoichiometry videos. Last time we covered mole to mole equations and some mole to grams, and just as a quick review, we can talk through a mole to gram equation. Here it's all worked out for you. Photosynthesis, plants use energy from the sun to produce glucose, and they also use oxygen from produce oxygen, from the reaction of carbon dioxide and water. So, what mass in grams of glucose is produced when 3 moles of water react with carbon dioxide? So, first, we have to create a balanced equation, and this one is balanced. Second, we need to find the mole ratios. Okay, we're looking for moles of glucose and moles of water. So our mole of glucose, we have 1 mole of glucose, no subscript in the front, and we have a 6 in front of the water, so it's 6 water. So our ratio is going to be 1 mole of glucose for every 6 moles of water. So we write down what we're given, 3 moles of water put into this equation, and then next we use our mole to mole ratio, 1 mole of glucose every 6 moles of water. And now we're going to convert to grams of glucose. The molar mass of glucose, 180.1 grams over 1 mole. And we can cross out units to make sure we have it right. Moles of water top and bottom, moles of glucose top and again bottom. We're left with grams of glucose, which we want. Simple matter of pushing buttons on a calculator gives us 90.1. Okay, let's move on to a new type of problem. Grams to moles. This is the exact opposite, where now you're given grams and you have to find moles. Okay, given this equation, which is balanced, 4 ammonias plus 5 O2s, 4 NOs, and 6 waters, the reaction is run using 824 grams of ammonia and an excess of oxygen. Excess of oxygen means you're not going to run out, limited supply, so we really don't need to worry about this. So, how many moles of NO are formed when we input this much ammonia? Okay, first you're going to write down your given, and with technology being as amazing as it is, we see here we have 824 grams of ammonia. Next, we're going to need to convert those grams of ammonia to moles. So we put 1 mole of ammonia over the molar mass of ammonia, in other words, the mass of 1 nitrogen and the mass of 3 hydrogens, 17.03 moles of ammonia over the 1 mole of ammonia. And our final section here, our mole to mole ratio, which we learned about in our last video, and we're dealing here with moles of ammonia, so there's 4 of those, and moles of NO, 4 of those. So in reality, that's not going to affect our calculations. 4 over 4 is just going to cancel out, but just the same, we're going to put it in there anyhow. Okay, now let's make sure we have our right units. Grams of ammonia top, and typo here, that should be a grams, sorry about that. Grams of ammonia bottom, okay, moles of ammonia top, moles of ammonia bottom. We're left with moles of NO, which is what we're looking for, moles of NO. And so our final answer, 4.8385 moles of NO. Okay, now that you know how to set those up, we've got another one here, the grams to moles. You can pause the video, read through it, take a little time, do some calculations, and see if you come up with the same answer, which I'm about to reveal right now. You should get about 0.1 moles of K2PtCl4. All right, well, let's move on to our last and longest type of stoichiometry problem. Okay, we have a compound with platinum, chlorine, ammonia. It's an effective treatment for some cancers. It's synthesized by the reactions shown in this equation. And we need to find out how many grams of ammonia are needed to produce 38 grams of this cancer treatment. So we have the grams given. We're given 38 grams of this platinum fluoride and ammonia. And we need to convert that to moles, so we need the molar mass of it on the bottom and 1 mole of it on the top. That's our conversion. Each mole of that molecule weighs about 300 grams. Okay, next we need to go and do our mole to mole conversion. So if we have moles of this compound on the top and the next one, so we can cross cancel, we need to have moles of it on the bottom. And we're converting to ammonia, so we'll need moles of ammonia on top. Okay, so it appears there's no subscript here, so it appears we only have 1 mole of it, so there should only be 1 mole on the bottom, which we have. And on the top it shows there's a 2 for a subscript here, meaning 2 moles of ammonia. So we should have 2 moles of ammonia on the top. Looking good so far. Okay, and last step, we need to convert from moles of ammonia to grams of ammonia. So we put 1 mole of ammonia on the bottom and the molar mass of ammonia on the top. In other words, the mass of 1 nitrogen atom and 3 hydrogens. Just as we calculated earlier, last video, 17.03 grams of ammonia. So after we push all our buttons on our calculators, we should come up with an answer of about 4.314 grams of ammonia. Okay, here I have another practice problem for you. Taking a lot of the word problem out of this one. If you take some time to look at the equation, it's balanced. Read through, lay everything out the way you need it, do your calculations, and then I will erase the answer. Again, feel free to pause the video. I start erasing the answer and you should get 117.6 grams of tin fluoride. Well, I hope this helps you to understand stoichiometry a little better, and look forward to seeing you in some, or hearing from me rather, in some future videos.